Okay, we're back doing some proofs, and we're going to step a little bit closer to actual geometry proofs. And we're going to be in section 2.7, and we're going to be proving segment relationships. And that's a fancy way of saying we're going to be doing algebra with some segments. But before we do, we're going to write down 3 more properties. And these are going to be properties of congruence. And if you remember, our algebraic properties were all properties of equality. So slightly different, but still very similar. So properties of congruence, there's going to be 3 of them. It's going to take 3 lines to write them. So our first one says reflexive property of congruence. So you can go ahead and think about us making a little table with 3 lines if you want. And it's going to say that if we have a segment AB, it's congruent to segment AB, which basically says if something's congruent to itself, right? That's an example of the reflexive property. Okay, our next property is our symmetric property of congruence. And it says that if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. It's just basically saying that you can flip the order of things. So remember, symmetric is the one where they flip. Reflexive is where they're exactly the same thing on both sides. All right, third one, transitive property of congruence. It says if AB congruent to CD and CD is congruent to EF, then AB is congruent to EF. And this is another example of that law of syllogism. We say if this is congruent to this, and then that same thing is congruent to another thing, then the first thing and the last thing are congruent. So let's do a quick example utilizing one of these. So we're going to start with given that M is between N and O. Prove that X equals 5. Now, that probably doesn't make a lot of sense, but we're going to add a little picture of this that will help. So when we first start out, our proofs are going to have pictures with them. As we get moving and we get a little better at this, our proofs are not going to have pictures with them. So for now, let's reproduce this picture in your notes. All right, so here is our segment NO with M between N and O, and here are some algebraic expressions for all these different lengths and distances. So we're going to start by proving this, and we're going to do it line by line. So line 1, we're going to say M is between N and O. And our reason is that was given information. We already knew that. Now, when we look at this problem, the way we want to solve it, and you don't need to write this, but this is what we want to do. 2x plus 3x minus 9 equals 4x minus 4. Right? We want to set it up and say that this part plus this part equals the whole thing. But we can't just do that when we're doing a proof. When you're doing a proof, you have to assume that the person reading the proof knows nothing. You have to tell them every step. So due to the fact that m is between n and o, we can say that nm plus mo equals no. And somebody might say, why on earth would you say that? How can you justify that? What's your reasoning to say that that piece plus that piece equals the whole thing? And you'll very calmly say, because you know the segment addition postulate. And that's how a proof works, is you justify every step. Now, we'll go to the next step, and we can go ahead and say that 2x, which is nm, plus 3x minus 9, which is mo, equals 4x minus 4. But why were we able to do that? What property allowed us to say that nm is now 2x and mo is now 3x minus 9? That's called substitution. Substitution. And that's the substitution property of equality, but we're just going to say substitution. Anytime you substitute something, just say substitution. All right. Number 4. And this is where you're going to want to work on your algebra a little bit. So 2x and 3x need to be put together. So now we have 5x minus 9 equals 4x minus 4. So why did we do that? What was the reasoning for that? You know, that was we didn't do anything to both sides. That wasn't a property of equality or a property of congruence. What we did was combine like terms. So we're just going to write that down. And it's kind of like we're like making a little map of every single step and justifying every single thing. Now, to solve this problem, solve this algebraic equation, the next thing we would do is subtract 4x, right? But that doesn't really, that's not our next line. Our next line needs to be what happens after we subtract 4x. So now we have x minus 9 equals negative 4. And the reason we were able to do that we were able to subtract the same thing from both sides and have it still maintain an equal equation, is that we use the subtraction property of equality. And now we got to go and do our last step where we add 9, and we get down to our 6th line. It says x equals 5, which is good because that's what we were trying to prove. But the reason that x equals 5 is because of the addition property of equality. So there's another example of a proof. We're going to practice these a lot. So the things that will get you in trouble, the things that you'll miss, these, people are pretty good at these. This one are the ones that people skip. It's not logical to say that because m is between n and o, that 2x plus 3x minus 9 equals 4x minus 4. You need to say that nm is 2x and mo is 3x minus 9. So that's what this step in the middle does, this segment addition postulate. So look back over that. We're going to practice a lot of these. You're going to get good at them and you're going to love it.